So application of quadratics means that some of what we're going to do is going to require quadratics, but there's going to be some stuff in here that you're going to recognize as something else, okay? Using a different formula or equation, okay? The first one is that, all right? So I'm going to draw you a little picture here. We're going to start out, we have a building here. Here's our big, tall building, all right? And then we have a ladder leaning up against this building. There's our ladder. And then down here is our nice green grass that the ladder is sitting on, okay? They tell us that the ladder is 30 feet long and that the base of the ladder is 10 feet away from the base of the building. Right? We are assuming that the building is upright. So what have we created? A right triangle, right? So what formula, what theorem can we use to solve for the height of the building? Jude, what'd you say? Pythagorean's theorem. So we're going to use a squared plus b squared equals c squared. Which one has to be c? 30 has to be c because that's our hypotenuse, right? We're going to say this is a and the 10 is b. All right, take 3 minutes and see if you can solve for the height of the building. All right, we do not want to leave this in radical form. Okay, I want this to be something that we could look at a tape measure and what we're doing right now is we're hanging up a big giant banner of whose face? Braden's face. It's baseball season. Hanging up a big giant banner of your face on this building like they do with Caitlin Clark and Harper Murray and Lincoln. So we got to see how tall this banner needs to be. All right? A squared stays as a squared. What's b squared? What's 10 squared? What, Grace? 100. What's c squared? 30 times 30? 900. So then I subtract 100, right? I get a squared equals 800. So then, Jackson, what do I have to do with that to solve for it? Square root. A equals 28.28 feet. Okay? So 0.28 is just over like 1/4, right? Because 0.25 would be a fourth, right? So if we wanted to put this in feet and inches, I'm stretching the problem a little bit here. This would be 28 feet and about how many inches? If it's 0.28, like that fractional part, what would a fourth of a foot, right? How many feet are in a foot? Or how many inches are in a foot? 12. So what's a fourth of a foot? Grace, you said it. Not 30. 3. Okay, 3 inches would be a fourth of a foot. So this is going to be about 28 feet, 3 inches. In your calculators right now, type in 0.28 times 12. What's it give us? 3.36, right? So just over 3. All right, so now Braden's banner with his face on it, getting ready to pitch for the Titans, has to be 28 feet, 3 inches long. We're going to hang it up on this building, all right? Next one. You guys ever been cliff jumping anywhere? Where at, Malaya? Okay. Anywhere else? Aiden? Okay. My wife and I went on our honeymoon in Jamaica in 2015. One of the excursions we went on was to Rick's Cafe in Jamaica. Okay, Rick's Cafe, you jump off of cliffs into 7 Mile Beach, The water is completely clear. It's beautiful. They have different options, but the highest option they have is 30 feet. Okay, so we did the 30-foot jump. This guy, his name is Spider. Spider is a local Jamaican cliff jumper. Hey, these guys free climb, means no harnesses, no ropes, up these cliffs. And then at Rick's, they have this extra pedestal that's even higher up. So this is in 2014, a year before we were there. But this is exactly what it looks like.
All right, GoPro Jamaica, no problem.
This is his view. So that platform right here is the 30-foot platform. So this one's 30 feet above the water. Okay, I jumped off that one. Okay, he's about twice as high. It's about 60 feet off the surface of the water. So Rick's, they have there's a stage underneath that little cabana there. At the other end, there's live music playing. They've got the bars and the pools and everything, and it's right there on the coast. But that cliff right there that he's showing, there's that guy with the red shirt on it. You see that? That's what they free climb up. They're almost upside down for part of it. And then they climb up and they get on this. See that tiny little platform? And these guys do this for tips.
Yeah, I'm ready. All right, good. What's the theory? Come on then. Hey, my friend, get ready. Tell everybody to get ready.
They flip and spin and do all these tricks.
GoPro, no problem, Jamaica.
Some of the funniest, awesome, kindest people. But it was a pretty awesome experience. Connects to this problem. So this cliff diver is 40 feet above the water, okay? And for this equation, h is the diver's height above the water, and the t is time. Okay? So we could put in a t for time. So let's say half a second. After they jump, half a second, how far are they still above the water, right? Well, in this case, before we start on the equation, what's the maximum that they could be above the water? What do they start at? 40 feet, right? Okay. So over the course of time, they go from 40 feet above the water to 0, right? When do they get to 0 feet above the water? When they hit the water, right? Okay. So what we want to know is how long is the diver in the air? So what are we going to substitute here? We're trying to figure out the time, how long. So Malaya, what are we going to substitute? Yeah, we're going to make h 0. So it's going to be 0 equals negative 16t squared plus 40. Now on this one, we don't have a b, right? We don't have a b value. So we can use our property of squares. So from there, I want you to solve for t. If you don't have a calculator, get it out or let me know. Oh, short. All right, we should get 2 answers, right? If we do this the right way, because we have a square root, right? Okay, so we subtract 40, then you divide by 16, negative 16. So we end up with what? What's this part? We end up with t squared equals what? 2.5, right? Okay. So when we type this in to our calculators, we can get one of 2 answers, right? What's the first one that we get? What? 0.5? It's not going to be 0.5. 1.5, isn't it 5, like 5.4? 1.58. Okay, or it could be negative, right? Because it's a square root. Now, in this case, which one doesn't make sense? The negative, right? We can't have negative time. Okay, that's going to come up today a little bit more. We can't have negative time, so it's 1.58 seconds is how long this cliff jumper's in the air. Okay, questions on that? How we got there? I know I skipped a couple steps. Malaya?
I just have a question.
Yeah.
Like on the test or something, will you take points off if we don't put like seconds?
I don't think so. I'm still learning about that sort of stuff.
Okay.
Do other teachers?
No.
I'm usually not petty like that.
Okay.
Okay. All right. This one, last one we're going to do, talking about blood pressure. Okay. It looks scarier than it is. Okay. P represents the actual blood pressure. They say it's the systolic. You know how when you get your blood pressure, there's a top number and a bottom number. Systolic is the top number. Okay. So we're talking about systolic blood pressure and age. So capital A stands for the age. Okay. What we want to know is what age would it be normal for a woman to have a systolic blood pressure of 115? So where am I going to plug that 115 in? For which variable? P or A? Is the 115 the pressure or the age? Pressure. We're not talking about a lady who's 115 years old. Okay? So we're going to plug that in. 115 equals 0.01A squared. And so on. Okay, now, this goes back to our bell work today. If we want to use like our quadratic strategies here, we have to set it equal to what? 0. So some of us want to subtract that 107 right away. We actually have to go the opposite direction. We want to subtract the 115 over. So now it's set equal to 0. And then this is going to be minus 8. Now, am I going to be able to factor that? Probably not with all those weird decimals, right? So what strategy do I have to use? Quadratic formula. For those of you that don't remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what you're going to have to do is put your pencil in your hand and plug those values in. This is our B, this is our A, this is our C. purple is with everything just plugged into its place. Then we simplify it. After we simplify everything, we should get that. Why did I just duplicate that and create two separate equations? Because I have that plus or minus. Good. All right, so over here, we're going to make this one green. We're going to make this one red, orange, actually. Okay, so when I solve the green one, I'm going to get a reasonable solution, right? Has anybody done that one yet, the green one? What'd you get, Jude? 13.375. Did you divide it by 0.02? I think we should end up with 26. Should be 26. Do the square root first. I don't think so. I think you got a. So the 0.25 comes from this right here. So that would be this. The 0.05 is going to give us 0.0025, right? Right, and then the -4 times 0.01 times -8 gives us 0.32. So if we combine that, that's where we get the 0.3225. Did you have the 3225? Maybe you forgot to add together?
I did the right side first.
All right, let's look at it here. Let me see. I'll split my screen here. All right, the square root of 0.3225 equals
0.567.
that. Oh, I'm not projecting. There we go. Okay. So 0.567 or 568. So we'll call it 568. So -0.05 plus 0.568 equals that divided by 0.02 equals 25.9. So I guess, yeah, it is round, but it's to 26. Okay, the other one, here's my point. We get a negative number, right? For the other one. We get negative something. Is it the same number? No, it's negative something. But in the terms of this problem, does negative something make sense? No, it doesn't make sense because we're talking about age. So the only correct answer is 26. It would have to be 26 years old. So at 26 years old, we would expect the normal systolic blood pressure of a woman to be 115. Okay? Any other questions about that?
Do you just want us around scenarios whole number when it comes to age and stuff like that?
Yeah, probably.
Okay.
Good question. Okay, that is not what we're doing. I have a worksheet for you. So,